Welcome to the tutorial for the Coastal Model Repository, or CMR. The web page for this tutorial is here. If you enter that in your browser, you'll be able to click on the links and copy-paste the relevant commands. In order to run the CMR, you will need to download 6 things. One of them is optional, that you will only need if you're on Windows. And then the last step is running the CMR. Okay, so you'll need Docker Compose. You'll need a login either to Agave or Tapas. Possibly you'll want both. Fourth, as I say, is optional. This is only if you are running on Windows. My belief is you'll want to have the Windows subsystem for Linux, or WSL. Getting Docker to work on the WSL requires a few special steps. Just in general, for your Linux WSL environment, I recommend installing the WSL terminal and using that instead of the default bash. And for X Windows applications, should you want to use them, I recommend VCX. You have to start that up every time you start Windows. And finally, I recommend that you make your home directory under Linux a symbolic link to your Windows 10 home directory. That's just for convenience with copying things back and forth. You'll want to get the Docker Compose.yml file for the CMR, and you can run this command from a bash window, and this is just a curl command to get the Docker Compose. Finally, you'll want to do a Docker Compose pull to bring the image to your machine. At this point, you will have completed the install. This last step you can run whenever you want to update the image. Finally, you start the image by running Docker Compose up. Next, we'll take a look at doing these last two things from the command line. We will now complete the installation of the CMR tool using the command line. The first step is to use the curl command that was in the web page. We just pasted it here, and I can run it. You might have to install curl on your Linux system. It's as simple as apt-get install curl if you're on Ubuntu. In any event, we now have the file downloaded. Let's take a look at it. At the top there are some comments that talk about how to use the CMR. First, Docker Compose up to get the thing running. Docker exec -it CMR bash. Once it's running, this will take you from, it will be like SSHing into the image. It will give you a shell inside the image. This is an alternative to getting a terminal from the Jupyter menu. You can also copy files in and out of the image using the docker cp command and using the image name CMR. The volumes give you permanent storage inside the image so that work that you do from one invocation to the next will persist. And then there's the port. Now, if you want to change the port number for some reason, if you don't like the port 8002, you just need to change it in all 3 places. I want to use 8004 for my own purposes, so let me do that. Docker Compose pull. Okay, this will pull the latest image from Docker Hub. In my case, it won't take that long because I should have an almost current image already. Okay, now that we've got a current image, we can say Docker Compose up. And as Docker Compose comes up, it will print a bunch of stuff to the screen telling you things about what it's doing. You don't need to pay attention to that. The important point is this link here, which is what you need to start your tool. So you want to copy that. Okay, so that's the second part of this tutorial. Okay, so now we're going to start using the CMR. We've taken the URL that we received from the last part and pasted it at the top. We get the following display from Jupyter. We're going to click on model.ipynb. We should see a single cell with input new model. We're going to shift enter in that cell. I'm going to use an Agave login, so I'll put that there. My Agave username is this. Enter my password, which you cannot see. You will see some output on the screen that happens the first time the CMR is run. I now have the tool open. What I'm going to do first is I'm going to run Swan. So by default, the directories are populated to run a default Swan job, a default FunWave job, and so on. Let me just show you how that works. So if you want to look at at what's in there, you can look at the terminal that you can get from here. So these are the files that these are the input files that Swan uses by default. Okay, so let's just run that job. In order to run it, we go to the Run tab. You can either adjust your NX, NY, NZ, the number of processes that you will run on the remote system by dragging the sliders or by typing. I kind of like typing. Let's call this Swan Demo. Just give it a name. All right, and once I've got that all the way I want it, I'm going to click Run. Some text will print below showing me what it's packing into the run directory and how many processors I'm using and my job ID. I'll go over here, I'll list the jobs. Currently my Swan demo is in the staged state. I can periodically refresh that and get the new state for the job. Over here I can look at the job history. This is more of a debugging tool in case things go wrong. If I want to stop the job, I can hit abort at this point, but I'm not going to. So let's go through the stages. We're now queued. Okay, it says we're finished. This is a very fast job, so I'm going to list the output. Okay, so Swan prints all these output files. Let's just look at say, no, let's not look at that one. Let's look at the standard output file. So you look for something that has a .out in the name. This is the standard out from the job. Let's download that. You print download. That comes out here. So on Shelob you get a Prolog script output because that's just part of the way all jobs run. Then you see the Swan output, and then there's the epilogue script. So that ran successfully. Okay. Next, let's go back and do an NH-Wave job. In some ways, that's a little more interesting. So NH-Wave has this possibility of choosing templates, and I've got two different templates here. Here you can choose various parameters of your job. Now, this is customizable, this GUI, and let me show you how this works. Let's go back to the command line. So you notice there are these files, input template, input template 2. So if I want to go to input template 2, all right, I can see the various possibilities. What I want, if I want something to show up in the GUI, I give it a label and a value, right? So here I forgot to do the K-glob. So label equal cells in Z, value equal 4, okay? PX and PY are the number of processes in the X and Y direction that NHWave uses. Okay, so I'll save that, and I'll come. Okay, so save and exit. Let's go back to here. Okay, so to get the template refreshed, I'll just go to the basic and then back to the advanced. And now I have a number of cells, the cells in Z, and I can update that file with clicking this button. So, and that prints out at the bottom here that it updated the NHWave file, input.txt. If I want to add a file to the input NHWave directory, I can do it two ways. I can use the command line in Docker CP from outside the Docker image. I can copy a file in, or I can use this upload button, and I'll just sort of randomly upload an image file. And when I do that, there's a slight delay, and then I see upload of image was successful. Okay. So now I can run an NHWave job, just as I ran the Sheilab one. The NHWave job takes a little longer to run. We're currently queued on the Sheilab cluster. Now we're running. Running will take just a little bit. Okay, the job is now finished. I spliced out the time there, so it didn't look as long as it actually was. Okay, and let's take a look at the output file, as before. And now we scroll down to the bottom, and we see this output from NHWave, so that worked. Okay, that includes the basics of running jobs. The other thing you can do is you can build. You can select your version. This says Swan version over here. This is something I guess I have to fix, but it's showing an NHWave version. Let me just try refreshing this. Yeah, so the versions are updating, but the name isn't. So that will be fixed, even if this tutorial shows it wrong. All right, so that concludes our tutorial. Thank you for your attention.